Hello, algebra students. In this lesson, we're going to look at how to define and use sequences and series. So this is the first video and the first lesson of our newest unit that we're starting in second semester. So to fill in a few things, first of all, a sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it is understood the domain starts with 1. The domain, remember, meaning these are the numbers that we're plugging into the function or the rule. The values in the range are called the terms of the sequence. Now, to give you an example of what that would look like, the domain is going to be something like 1, 2, 3, 4, etc., all the way up until n, depending on the number of terms that exist in that sequence. The range sometimes is considered this way: a sub 1, a sub 2, a sub 3, a sub 4, etc., all the way up to a sub n, meaning the first term, the second term, the third term, the fourth term, or what is the term when I plug in 1? What is the term when I plug in 2? What is the term when I plug in 3? And so forth. A finite sequence has a limited number of terms. And on the contrary, an infinite sequence continues without stopping. For example, if I was working with a finite sequence, it'd be something like 2, 4, 6, 8. Stops right there. That's it. 2, 4, 6, 8. There's my sequence. 2 is the first term, 4 is the second term, 6 is the third term, 8 is the fourth term. An infinite sequence, I might look a little bit different. Maybe 2, 4, 6, 8, comma, dot, dot, dot. Just showing the ellipsis, it says this goes on forever and ever. There's no stop. So that would be an infinite sequence as opposed to a finite sequence. Now, a sequence can be specified by an equation or a rule. For example, both of these sequences can be represented by the same rule. A sub n, meaning to find the nth term in my sequence, I take 2 times n, n being the number of that term. For example, if I wanted to find what's the third term, I'd be able to plug in 3 for n. Well, 2 times 3 is 6. That's right, that was the third term. Or I could write it as f of n, in function notation. We'll use either of these, probably more commonly this method, a sub n. Putting that to use, let's write the first 6 terms of the following sequence. So here we're given a rule for each sequence, and we have to write out the terms. Now remember, as we do this, what we're doing is we're writing out the first 6 terms. Is essentially we're plugging in for n, we are plugging in 1, and then 2, and then 3, and then 4, 5, and 6. Okay, so a sub 1, the first term, is what I get when I plug in 1. When I plug in 1 for n here and here, that'll be 1 over 1 plus 1, which is 2. All right, 1/2. The second term in this sequence will be plugging in 2. 2 over 2 plus 1 is going to be 2/3. The third term in this sequence is going to be 3/4. And the fourth term is 4/5. Get the idea? I'm plugging in the value of the term in for n in both parts. And the fifth term is 5/6, and finally the sixth term in my series is 6/7. So you can write those out with commas if you're asked to. Usually you see sequences written in a list with commas in between each term. Next, sometimes we're going to find the first 6 terms of this sequence. Okay, we'll plug in 1. 1 minus 1 is 0, and negative 2 to the 0 power is 1. Okay, comma. I'm not going to write all these. Second term, plug in 2. 2 minus 1 is 1. Negative 2 to the first power is negative 2. Plug in 3. 3 minus 1 is 2. Negative 2 squared is positive 4. Next term, I plug in 4. 4 minus 1 is 3. And negative 2 cubed is negative 8. And then plug in 5 for the fifth term. 5 minus 1 is 4. Negative 2 to the fourth power is positive 16. Now you notice the sign keeps changing each time because my negative is inside of parentheses. So when I raise it to a power, it's going to change. When it's odd, it will stay negative because a negative number raised to an odd power stays negative. But a negative number raised to an even power will become positive. So I'm going to go positive, negative, negative all the way. So this one, by that pattern, should be negative. Plugging in 6. 6 minus 1 is 5. Negative 2 to the fifth is indeed negative 32. So there would be the first 6 terms in that particular sequence.